this lesson builds off of what we did in 7.7. I'm just introducing 3 new, very, very important trig identities. So let's call them number 1, number 2, and number 3. But I'm going to take 1 minute to show you where the heck these identities come from. And it's called the Pythagorean identity because it's derived from the Pythagorean theorem, which we'll remember is x squared plus y squared equals r squared. So let's start here and see how we can come up with this ourselves. Okay, I want to go ahead and just bear with me for a second, play along. Let's divide every term by r squared, which is totally possible, right? If whatever we do to one side, as long as we do it to the others, we are good to go. So when I divide everything by r squared, notice this side becomes 1, and then ooh, this looks very familiar. X over r. Do you remember what that formula is? It's cosine. So cosine theta, but then it's being squared. So we'd write cosine squared theta. Plus, and then y over r, that's sine. So cosine squared theta plus sine squared theta equals 1. Check it out. That's the exact same thing we have down here. Pretty neat. Okay, so now we know where the first formula comes from. Let's look at the others and derive them in the same way. This time, instead of dividing everything by r squared, let's divide everything by x squared. Okay, so x squared over x squared just becomes 1. Y over x, that's the tangent formula. And then r over x, see if you remember, r over x is the opposite, the reciprocal of x over r, which is cosine. So this will be secant squared theta. And lo and behold, that's formula 2. See if you can figure out how to come up with formula 3 on your own. So take a minute, pause the video, try it yourself. So, did you divide everything by y squared this time? It's the only guy that's left over. What happens when we do x over y? Which formula is that? You should recall that's cotangent squared x. The y's cancel, gives me plus 1, and then r over y is cosecant squared x, or cosecant squared theta. And indeed, that is formula number 3. So you can see that all of these identities come from the Pythagorean theorem. They're all related to the way that the sides of our right triangles work, and hence they're called our Pythagorean identities. So keep them numbered 1 through 3, and let's see if we can't verify some of these problems. So the only thing that sets today's lesson apart from yesterday's is now we have an equal sign. So here's how we'll go about it. Step 1, you're going to choose the more complicated side to work on. Step 2, you're going to simplify that side only. So you're only going to work on one side at a time. And then you're going to verify basically that the left side equals the right side. So watch me do the first one. Okay, let's draw a dotted line down the middle, down the equal sign. And let's choose the more complicated side. So my more complicated side is definitely the left side. And remembering our rules from yesterday, remember we want to convert everything into sine and cosine. So if it already says sine or cosine, you can leave it alone. But otherwise, we want to convert it. So this time I have 2 terms, and I'll convert both of them. So tangent is sine theta over cosine theta. Cotangent is cosine theta over sine theta. Don't change anything on the right side, just bring down the equals 1. So we chose to work on the left side. Let's see what happens. Well, the sines will cancel, the cosines will cancel, so I'm left on top with just 1 over 1, which does equal 1, and we're done. That's how verifying works. it's kind of even easier than yesterday because you know what your final answer is supposed to be. We know that we're supposed to get 1. So that's pretty cool. Let's try number 2 together. Okay. So 2 says 1 minus sine squared theta over cosine theta equals cosine theta. So the rules are pick the more complicated side. Let's draw the dotted line down the equal sign to keep our work neat and separate. Okay, I see a 1 minus sine squared theta on top, and that looks kind of familiar. It's almost similar, so it's kind of similar to formula number 1. But formula number 1 has a plus sign and a cosine with the sign, so we have to make some changes. My challenge to you is, can you move things around here so that you have 1 minus sine squared theta? Give it a try. Pause the video. So some of you may have gotten it, some of you may need a little guidance. Let's see. If I want 1 minus sine squared theta, then this sine squared, I should move it to the other side so that it can become negative to match this here. So let's subtract sine squared on both sides. And lo and behold, we're left with cosine squared x on the left equals 1 minus sine squared x on the right. That's great news because if I want to simplify, then the way things currently stand down here in number 2, nothing can cancel because of this minus sign. In case you're wondering, hey, why don't we just cancel stuff? Well, because there's a minus sign here. But we know now that 1 minus sine squared theta, or 1 minus sine squared x, is the same as cosine squared x. Oh my God. Using a little manipulation. So let's replace the numerator with cosine squared x based on our reworking of formula 1. Now, we're going to see this come up again and again, so let's give this formula a name and call it formula 4. So cosine squared can be rewritten as 1 minus sine squared. So now that we rewrote the top, let's keep the bottom cosine x. Whoops, I should write theta, since that's what the problem had. And remember, we don't touch the right side, we just copy down. Now, does the left side equal the right? Certainly does. We just have to cancel 1 cosine on the top and bottom. And that leaves me with cosine theta equals cosine theta. Since they match, I'm going to put a check mark to show that this identity is verified. Okay. So we'll do number 3 together. So let's choose the more complicated side. Take a guess which side looks more complicated to you. So I'm going to work on the left side because there's a lot more going on here, and draw my dotted line down the middle. So the right side will not change. I'll just keep it equals sine theta, cosine theta, every step of the way till the end. But on the left side, let's see what we got. Well, this guy looks really familiar, doesn't he? 1 minus sine squared theta, that's formula 4 right here that we came up with earlier. So let's replace 1 minus sine squared theta with its equivalent expression of cosine squared theta. So we have tan theta, parentheses, cosine theta now. And at this point, it's looking a lot better because at least there's no more minus sign on the left, but it's still not equal to the right. So let's use our normal strategy of changing everything to sine and cosine. So tangent can be rewritten as sine theta over cosine theta, and we're multiplying this by, oh, actually, I'm so sorry. 1 minus sine squared theta, did you catch my mistake? Should be written as cosine squared theta, because that's the formula. It involves squares on both sides. Okay, I was about to get the wrong answer. Over 1, so we can now multiply straight across. And now notice we can cancel this cosine with one of these cosines, leaving us on the left side with sine theta cosine theta equaling sine theta cosine theta. So again, that's the nice thing about these problems. If I didn't know that this was supposed to equal sine theta cosine theta, then I wouldn't have caught my mistake. I would have just left that and canceled all my cosines on accident, and then I would have just had sine theta on the left. But because I know what the final answer is supposed to be, it makes my life a little easier than the last lesson that we did. So let's box our answer and draw a check mark. Great, now that we've done numbers 1 through 3, you go ahead and try for yourself. Okay, so you've given number 4 a shot. Let's see how you did. The denominator, we should replace, oh, yeah, we're working on the left side, by the way, because it's more complicated. So the denominator, we should have replaced it with cosine squared theta. And notice I left the numerator the same. Equals tan squared theta. And then sine over cosine is tangent. And since it's being squared, our final answer is tangent squared theta equals tangent squared theta. And we're done. Let's put a little check mark. Or some of you guys like to do this. I'm all about that too. Okay, 5 I want to do with you because this is one of those problems that actually you can do in more than one way. So I'm going to show you first a way that you could do this problem by breaking our rules, okay? So remember the rule that says only work on one side? Yeah, we're going to break that rule. For this problem, we're going to work on both sides, okay? So check it out. Unlike the previous problems, I can't replace this using our formula 4. Why not? Well, formula 4 involves 1 minus sine squared, but we only have sine. So we can't use that formula. And 1 minus sine, you might be thinking, oh, well, just get rid of the squared on the cosine too. But that's not how that works. That's wrong. So if we can't use formula 4, I'm going to break our rule for just a second because I'm noticing that if I multiply this sign with this sign, I will get sine squared. So my mind is working. Okay, how can I multiply those? Well, why don't we clear the fraction? Okay, for this problem, we can try to clear the fraction and see what happens. So how do you clear the fraction? You multiply every term by the least common multiple, or the least common denominator. So on the left side, I'll multiply. Let me actually rewrite this so I can get some more room. Okay, that's a typo. It should just say cosine squared theta. There should be no x there. So on the left side, I have cosine squared theta over 1 minus sine theta equals 1 plus sine theta on the right. So like I said, we're going to multiply both sides by the LCM. Putting this over 1, you can see that the least common denominator is just 1 minus sine theta. So let's multiply both sides by that. And if I do it on the left, I'll do it on the right. So on the left side, they're going to cancel, leaving me with cosine squared theta. Notice I'm working on both sides here because I saw a unique opportunity. And now you'll see why. Okay, don't forget that we have to distribute. We have a binomial times a binomial, so we're going to have to either box or FOIL. I'm going to show the FOIL way, so stick with me. 1 times 1 is 1. 1 times negative sine theta is negative 1 sine theta, or just negative sine theta. Positive sine theta times positive 1 is plus 1 sine theta, or just plus sine theta. And then positive sine theta times negative sine is going to give me negative sine squared theta. That's what I was trying to get. Now watch what happens in the middle. These are going to disappear, cancel each other out. That's negative 1 plus 1. The sine thetas cancel. Because did you notice this is actually like a difference of squares? It's flip-flop on the signs. Okay, so the middle term canceled, meaning that on the left I still have my cosine squared theta, and on the right I have 1. Whoops. Okay, and on the right I have 1 minus sine squared theta. Oh my gosh. This is formula 4. Oh my god. We were able to get our sine squared. The squared that we were missing last time. We got it now. So 1 minus sine squared theta, look at your notes, is the same as cosine squared theta. And so we have, by manipulating both sides, proved that this trig identity is valid. That in fact, cosine squared theta over 1 minus sine theta is the same as 1 plus sine theta. We proved that it's equal. That's so cool. Now, why did I give you a rule and then break it? Well, rules are intended to make your life a little bit easier by giving you a place to start. But as you see opportunities, don't be afraid to try different things as long as you're following mathematical principles. So as long as you multiply every term by the denominator, that's allowed. We actually have done that in class together. So don't be afraid to try new things is my point. But let's say you're like, no. That's not for me. I like the rules, Miss Name. Well, let me show you another way we can try number 5. Why don't you give it a pause and see if you can find a way of doing it on your own. Hint, where we only work on one side. So let's follow the rules. This time let's do method 2, where we only work on one side. This is your chance to pause if you want to give it a try. Okay, so I could realize that I need to simplify this so that it's just 1 plus sine theta. The only way that's going to happen is if my denominator cancels. The only way my denominator is going to cancel is if I have somehow a 1 minus sine theta in the top so that they can cancel. And guess what? I can make that happen by using rule 4. It says cosine squared theta is the same as 1 minus sine squared theta. So I'm going to use that. Instead of cosine squared theta, I'm going to write 1 minus sine squared theta on top. And the bottom, I'll leave it the same. Now, noticing that we have actually a difference of 2 perfect squares, zong, throwback, I can take the square root of this term and I can take the square root of that term. We can write them as binomials and then flip-flop our signs. So that's 1 minus sine theta times 1 plus sine theta. One minus sine theta. So just like we normally do, a squared minus b squared becomes a minus b parentheses a plus b. I can do the same thing with sine squared because sine times sine is sine squared. Okay, let's keep the right side the same per our rule. And notice magically on the left what cancels. Yes, these guys cancel. And so we can see 1 plus sine theta on the left equals 1 plus sine theta on the right. We have verified our identity. And we didn't even break the rules this time. So again, I want to show you that you can use multiple ways to do these problems. In some problems, there's like 5 different ways to do it. So it offers a lot of room for creativity. Okay, try number 6 on your own. Go. Okay, so tips. Remember, you want to work on the more complicated side. So for this problem, you should have worked on the left side. And, well, let's see what we can do. One thing we can do is FOIL. We've done that before. And indeed, that was the way to do this problem. Now, you could have done it another way, but this is like the most obvious way to me to do the problem, which is to go ahead and FOIL. So that's going to be 1 minus sine theta plus sine theta. And then a plus and a minus make a minus. Sine times sine is sine squared. I'm going to move this over so I can keep the equal sign in the middle. Keep my work nice and neat. And I'm not even going to touch the right side at all. Next, these sines cancel, leaving me with 1 minus sine squared theta equals cosine squared theta on the right, which still hasn't changed. Here's my dotted line, by the way. And then using rule number 4, 1 minus sine squared can be replaced with cosine squared theta. Ta-da! We verified. Okay, you try number 7 yourself. This is your independent practice problem. Work on the more complicated side. Use any rules, 1, 2, 3, or 4, to rewrite this. And don't forget, it's okay to make mistakes. Like, if you use the wrong rule, you'll figure out that you made an error. And then you just go back and try something else. There's no way you can, like, permanently mess it up. So you just try multiple things until something works. Cool, so for this problem, you could have done a number of things. You could have replaced the bottom using rule 4 with cosine squared theta. So that cosine squared over cosine squared gives us 1. Or you could have replaced the numerator with rule 4 and changed that to 1 minus sine squared theta. So that 1 minus sine squared over 1 minus sine squared also equaled 1. I'm going to do the first way. So I'm going to circle this. In my next step, the numerator stays the same. And the denominator, instead of 1 minus sine squared, I replace it. So 1 minus sine squared is the same as cosine squared. This way it's good to have your notes in front of you. Otherwise, you'll be struggling to remember these formulas. So the right side is staying the same, and then in the next step, I'll cancel. Anything divided by itself is just 1, and 1 is indeed equal to 1, check mark. Okay, you try 8 yourself. So hopefully you gave it an honest shot. Let's see what happens if we try to work on the left side, which is definitely the more complicated side. Okay, so that dotted line. All right, on the left side, I'm noticing sine squared plus cosine squared. That's a formula. That's actually the first formula that we learned. Coming back here, you see sine squared plus cosine squared is really equal to 1. Amazing. So we got to use formula 1 finally. Sine squared plus cosine squared is just 1. The denominator can stay, and the right side can stay. Next, if you remembered yesterday's rules, you know that 1 over cosine, or the reciprocal of cosine, is just secant. And since we have this squared here, it has to show up in our next step too. And just like that, in 2 steps, we're able to verify our identity. So there's nothing clever going on here, really. We're just seeing, what can we replace using these 4 formulas that we have.